Okay, good morning, everyone. Today, I will focus on the time-saving tools in our unitary controllers. We call them Nano Edge Engine Embedded, as well as Niagara Enabled. And we'll start with a short overview of what Nano Edge Engine is, and we'll jump between the tools, the presentation. Nano Edge Engine is our embedded software platform for edge devices. And we call it Nano Edge because it's ultra light software engine that can be installed on a microcontroller. I have an example here. This controller has a microcontroller inside. I can power it directly through the USB. It doesn't require 24 volt for programming, and I will speak more about that. It's tailored to be an edge device, ideally connected to both your supervisor applications and the cloud simultaneously. And it's an engine, which means you can create your own logic, program it in real time, integrate devices, collect data, expose data. It can do it all. There are some key features of Nano Edge Engine itself. It's freely programmable. It can run applications in a cycle, more than one. All the data is being natively exposed over open protocols, and the engine itself is modular, which means you can install libraries, and we also have SDK where you can write your own libraries in C#. License-free, we don't charge for any tools, and the entire engine is constantly being improved and updated. Every quarter we have a product release with new features. And currently we hold 3 line of controllers. We have our universal application controller Rack 18 with 18 inputs and outputs, real-time clock, 2 Ethernet ports that work in a fail-safe mode, so we can easily daisy chain them on the site, and actually you don't need then switches on those sites, and you can program it over Ethernet or the USB. Then we have our VEV14 IP controller, which has 13 inputs and outputs and the differential presence sensor as well as the onboard actuator. Same double ports on the Ethernet with fail-safe switch, so there are physical relays installed on the switch. Whenever one of the connected devices fail on the site, the communication still passes through. This controller stores logic internally and comes pre-installed with a configurable VEV application that can support up to 216 different types of VEV boxes. And about the configuration of the VEV, number of tools. So this is where the time-saving tool comes. We thought of many ways how you'd like to configure your VEV controller. So the easiest option is just to use the dip switches. So the very basic option, change the VEV to the VVT, set units from metric to imperial. You can do all of that from the dip switches. You can also use the control point panel, which connects to the VEV and is being powered up directly from the VEV, and use it to do the commissioning, configuration, and also balancing of the VEV controller. We also have 2 tools. In our portfolio, we're focused how you can configure your product in Niagara Workbench, but also how you can do that without the Workbench. So if you don't have Niagara project, you can still use the product. So we have iSMA Configurator, which is a free portable tool that will allow you to do all of the configuration directly in there for both configuration and the balancing. Same tool is available directly in Niagara Workbench as well. So we have IC Device Manager that is a clone of a standalone iSMA Configurator Windows tool. And last but not least, the new controller that is coming up to the market next month is our UEC28IP, our unitary application controller, 22 inputs and outputs, designed for edge use. It will come with a G36 application that's going to be pre-installed on the controller, but it's also freely programmable. And we'll focus on the programming and how we simplify the user journey with the tools we provide for our unitary products. So First thing foremost, you don't need to have 24-volt AC/DC or Ethernet cables to do the bench testing. You just need a USB-C cable. You connect it to the controller like I have here. Works on all of our products, and what it does, it creates an Ethernet interface here for you. So we have now a virtual Ethernet interface that we can access the controller with using our tools. And we'll go to the tools in a second. So I said we have a dedicated tools inside Niagara. And how to get those tools. That's also where we try to implement time-saving tools. We created a Windows software that integrates all of our workbenches, all of our modules for Niagara. So you don't need to install the entire workbench. You can just get the module you need and drop it into your Niagara workbench you use. So we don't license that to be used in our workbench. There's no license for those modules at all. To program our Nano Edge engine controllers, you need any tooling for Niagara module. It's part of our IC workbench, but you can just download the plugin from our IC Connect software, open the folder, the tool will open directly for you, and just copy the jar files to your Niagara instance. And once you do that, we can open the workbench here. And I have the any tooling installed. During the first connection, you will have the any tooling service that will allow you to connect to the controller directly over the USB. Because we emulate the Ethernet, you can also do the bench testing for your BACnet device. All of our Nano Edge engine controllers, they're Niagara native. So upon the first connection, you can just discover the controller on BACnet network. If you use Ethernet, you will just drop this extension to your BACnet device. This UAC28 IP, it has some points already on it. So you can discover it here. But we are going to connect over the USB now. So we have here the AnyTooling service. It will store all of your Any2 extensions. So we have 100 of VEVs connected on the site. It's just going to list you all the VEVs here with the IP addresses, the version of the OS, and all the parameters you need to know of. So what we can do now is we can just right-click on the USB device extension and connect to the device. So what is going to happen when I click OK? You will see that this icon is going to change from gray to green, and there's going to be a tree that appears here. So this is the connection, and the tree appeared. The Any2 device extension loads the entire tree from the device. And that's also time-saving during the maintenances. When you come to the site, you don't really know what kind of version of software we have installed. You don't have to worry about this. I have 1.12 version, which is an unreleased version of our Nano Edge, and I'm connected over 1.10 version of the Any2Link. And you don't need the same tools to connect because our Nano Edge engine is built this way that it takes all the tree from the device and just builds it on the fly in your tool. So the next feature we have in the Any2Link is a possibility to create cycle-driven multiple applications with our cycle-threaded system. So what does it mean is we have an application container where you can create more than one application that will run in its own time cycle. We also have network container, service container, and system container. It's all being loaded during that first connection. So in the application container, you'll build your applications. In the network container, you will integrate your network devices over BACnet and Modbus, either MSTP or IP. In the services, we'll do some configuration for tagging, for haystack, or trends. And system is all your system management. So IP address, DHCP, NTP services, all of that. So being a cycle-driven system, this is actually a time-deterministic system that can go up to 100 milliseconds per cycle for the application. So we can build in one controller, and this is what we do with our upcoming ZEC24 controller with DALI, is possibility to create an FCU application that doesn't need to be running in a 100 millisecond cycle, can run in 2 or 10 second cycle, but the lighting application will run in a 1/10 of a second cycle. So whenever you click to switch on the light, it's going to switch on immediately. So those applications run independently. You define the time cycle, and what's next? You have all those libraries you can build your application with, and as I mentioned, you can build your own libraries with our SDK as well. So it's a very scalable system and modular. And yeah, we can create our first application here. So there is one already. So if we connect to this controller, we can create a new. We can click OK. Let's call it. So this is our zones application. So we will integrate some VEVs to control their set points during this demo. So we have now two applications. They'll both be running in a 500 millisecond cycle. And let's go back here. Data points. In our system, we define network points and data points. And the network point is whatever you integrate to our system. So it will be our CPU units, it will be the VEVs to the unitary controller, actuators, anything that you will integrate over Modbus or BACnet. And the local IOs of the controller itself. And we don't really count them as a device or points. There's no license on the controller, but there's a limit of data points the controller can run. So in our system, everything is built around the data. We believe that the data is the king, and we prepare many ways to automate things with a NanoEdge engine. For example, native data exposition over BACnet and Modbus just when you drop the data point. So whenever you create your application and you want to expose it to Niagara, you don't have to do any manual linking. Every point is going to be available over BACnet itself. Same for our NanoWeb UI, which is an auto-building web server on the controller. So everything around the data again. And all the data support by default Haystack tagging. So you can tag your data points with Haystack. We actually built our UI with the Haystack tags as well. So the auto-exposition mechanism is one of the core functionalities of our controllers. And the main goal is just to make things simpler. Allow you to focus on the added value when you build the system and not on the manual operation like linking the network point to and exposing data over BACnet or Modbus. And when it comes to the, let's say, structure and how you build the application, we support and follow the Haystack tagging structure. So in our solution, you have the application container. Ideally, in the application container, you'll have your equipments, which can be the VEVs, can be the HUs, and the data points. And the equipments and data points you can tag. Then when you would like to do an integration over Haystack directly from the devices, you can integrate to your reference site over Haystack for the Haystack APIs. The data points can be also structured in folders if you have many of them. You can add your priority arrays that are going to be synchronized over BACnet. The data points can be configured according to the BACnet standard with input value or output types, and that's also being synchronized over BACnet. So whenever you drop your data point and you configure it as an input value, when you integrate that over BACnet, it's going to be input value. That data point that you configure as input value will be visible over our web UI, but will not be an editable. So it's all ecosystem that's synchronized when you configure your system. And as I mentioned, the tags, we support the Haystack 4 library, and we use this library also for APIs for building our UI. And the UI itself is a modern interface we'll build with React code. It's scalable, it builds itself, and just to ensure that you can focus on the actual application and you don't have to really think of the front user interface that is going to be used by the operators or the end users. It's just going to build itself for you. So it's scalable, it can be open on a web browser, on a smartphone, or a local HMI. And yeah, no engineering at all. It's just going to pop up as you build your application. We use tags to define how this application is going to look. So you can tag it with a homepage tag, so it's going to appear on the front. So you have some user-defined parameters, and by the way, you can just use any Haystack tags from the Haystack library. It's part of the system. All tagged equipments and data points are going to be visible under your application. And how we build it is just to make sure that it's just the same workflow as you build your application. So the web UI, it actually represents your engineering UI. So what you see on the web can be, if you wanted to, if you tag it with the web points, just your tree. So you can show exactly what you have in your application. So this is the tree inside the device for our VAV controller. So all the points that we want to display, there's hundreds of BACnet points inside our VAV controller, but only the one that we want you to have on the web UI are tagged and being exposed for convenience of local operation just through the web. All right, so let's go back and do some demo here. So we have our zone equipment, and right now we are in our nano controller connected over the USB. So we'll create our first equipment, and it's just right click. We'll call it VV1. You can see that when you click right on the wire sheet, you will have a dedicated menu just for our nano devices. So when you click and add the data point or a binary data point, it's coming from our nano system. It's not Niagara proxy point. And you have also just handy here all the libraries that are installed to this controller. So what we can do now is we can add analog data point. Let's call it room temperature. Just to make it live, let's add another, just to simulate the value of the ramp. You can configure the ramp, so we can set some offset here. Save it. Right now we can link it here to the point. So we build our first logic here inside our controller. We go to the room point. You can see that this point is now being natively exposed over BACnet and Modbus protocols. You can configure it the way you want, so you can disable either Modbus or BACnet if you don't use one of them. But by default, you have just all the data available on the network as you go. So here we have the configuration for the point. We can set a unit. So let's select Fahrenheit. And now we can change that this is an actual input here. So now this point is going to also synchronize as a BACnet object input. When you discover that over BACnet, it's going to be your BACnet analog point configured as an input. So what we can do now is we can do another analog data point, and let's call it set point. And build some logic around it as well. So let's say that we want to create some math here. So we want to have a schedule, analog schedule for our point. And we can set the schedule. So this schedule is also natively being shared over BACnet, so you can already discover it. But we want to have some default value here when the system is not occupied. So let's set it to 68. And let's build a schedule from there and set it to 73. Okay. So now our schedule is built. Every day we'll have, by default, the 68 Fahrenheit when it's not occupied, and 73, and let's do that, apply that date from Monday to Friday. So the schedule is done, we can go back. What we can do now also is add another analog data point, and let's call it set point offset. So that will be linked to the control point that is being connected to the VEV, so we can give the user this flexibility to apply, let's say, an offset from minus plus 3 Fahrenheit. And let's just create some easy math here and add it together. All right, link it to the set point. So we built a simple application here for our VEV. And I mentioned we have this nano web UI, right? So this is how it looks. We have that AHU application already. So if we refresh now, it's not going to be available immediately because you need to tag the data. And what we did is we created an auto tagging mechanism. So we only have here the zone, but no points are being added because we haven't tagged them yet. So what happens here with the tags, we'll go to the services and we will open our tagging service. Let's go to the VV1 and just apply the tags to all of our points we just added here. So now all the points are being tagged. We go back here, refresh the page. We go to the zones, we have the VEV, and we have our 3 points. You can see that the room temp has been already configured as an input. We cannot edit it. But those points are somehow editable, but doesn't look that good right now, right? So we would like to know that this should be -3 + 3. So for that, we go back here and open our offset point. And what you can see here, these are just the standard haystack tags we just apply to the device on the fly. And it comes from your haystack service inside Niagara. So what we can do now is just apply minimum value and maximum value, which is also a haystack tag. So from -3 to 3. But we also want to know that for the user that will operate it, that they have a nice widget that looks just like they want to apply it. So we can use a slider here. So let's save it. We have a slider and go back to the browser. And now our point is being tagged with the -3 + 3, and you can just apply the -3 + 3 offset for your set point value. So you can see it just is being synchronized and works on the fly as well. So this is one of the core features we have. So real-time programming inside the Niagara Workbench, building application around the data points. All the integration, as I mentioned, will be done here over the networks, where we can also use Modbus and BACnet, and for that we have built views for discovering devices for BACnet as well. So you can bring your devices, link them, create an application, create a visualization, and I mentioned that we also have separate tools. So one of the separate tools for our NanoEdge engine is IC tool. So what we are going to do now is connect to the IC tool, to the same USB device, and we can open our application. Our zones are here, our VEV is here, and we have the same logic available in a separate tool. And it's all real time, so even 2 engineers can work on the same controller. One can be Niagara Train and use Niagara Workbench. The other one can just use the IC tool. And some things we are working on in terms of even easier integration and configuration of the products. How much time do I have? Couple minutes, great. So we work on the customization for the NanoWeb UI, so you will be able to just apply your logo, change the colors to suit your system, add graphics to the application and equipment you have there. And another part of the feature set we work on is to have the schedules and alarms directly available on the web as well. So you can give the end user flexibility to just use the web UI and the building operator just to configure those from the panels. So I can show you a demo for that as well here too. So we can use the tool. We have our analog schedule. So what you would do is just apply your auto tags to the schedule. We have the tags. So we should probably just refresh our page here again. And we should have our schedule. And we can see in 54 minutes it's going to change to the 68 degrees. So here you can operate your schedule directly from the web. All right, so You can save that logic to your standard palette if you want to use that later. So you can just use it like you would use the standard Niagara logic. What we can do now is we can go to the BACnet device here for a second. So we go into BACnet. So I linked my BACnet device here so we can now discover all those points. As I mentioned, they are natively available. And let's say we have 7 of those VEVs available on the network. So we can just duplicate this device multiple times, and we just have 2. When we click Discover, now we have all of those points available from 2 VEVs, and this is also going to be visible on the web server just as we speak. So we have zones, now we have 2 VEVs. We can link those values directly to the VEV we want to work with. So the only problem is over the web, you can see we have 2 room temps, right? And which one is which belongs to which controller. So for that reason, inside our BACnet device, we created a special configuration for, we call it inheritance mode. Right now we are in the standard mode. When we change that mode to the double parent and save it, and we go back to our BACnet device in Niagara, and now we discover those points. It's using this equipment to name the points. So you can see now in the BACnet point, you know exactly from which VEV this room temperature is coming from. No linking, just one click, and all points are being just applied on the fly as we speak. Okay, and I think that sums up my demo.
Either way, it's summed up.
All right, so if you're interested in our NanoEdge, you can scan the QR code, and Sign, I will share with you more information after the trade show. And I'll take any questions if you have any.
Any questions? Oh.
I was just curious, you were saying that your controllers could be configured by a dip switch or your controller, thermostat, right, or your computer. I assume for it to do it from the controller or the computer, the dip switches would all have to be on 0. But please correct me if I'm wrong, but let's say somebody set a dip switch to configure. Would you then have the power to override that from the controller? Because my concern there would be, what if you found out after installation that you had some controllers misconfigured? Is that a question of having to get to the controller and change the dip switches, or not?
You can override it over network. So you can configure that directly on the dip switches, but there's a way just to override it over BACnet network whenever you need to.
That's what I was curious about. Thanks.